My name is Sid, and I'll be presenting the composition of transformations I used to move triangle A, the seating area, in my Central Park Commons project. This triangle represents the design for the seating area, and my goal was to use rigid geometric transformations to reposition it into the passive recreation area. So, originally, triangle A, or the seating area, was located in the cultural/formal gardens, with vertices at O located 3, 11, Q 3, 8, and R located at 6, 8. According to the park zoning plan, this area needed to be relocated entirely into the passive recreation area, or Great Lawn. To accomplish this, I used a composition of rigid motions, a reflection followed by a rotation. The first transformation I used in this composition of rigid motions was a reflection across a vertical line, x equals -3. After reflecting, the triangle's intermediate image coordinates became O prime, located at -9, 11, Q prime, located at -9, 8, and R prime, located at -12, 8. Next, I performed a 180-degree rotation counterclockwise about the point -10.5, 7. After rotating, the triangle's final image had vertices at O double prime, located at -12, 3, Q double prime, located at -12, 6, and R double prime, located at -9, 6. Because both reflections and rotations are rigid motions, they preserve distance, side length, and angle measure. To prove this mathematically, I use the distance formula. By calculating the distances between each pair of vertices before and after the transformations, I got OQ equals QR equals 3, O prime equals Q prime equals O prime Q prime equals Q prime R prime equals 3, and O double prime Q double prime equals Q double prime R double prime equals 3, and I also got OR equals 3 root 2, O prime R prime equals 3 root 2, and O double prime R double prime equals 3 root 2. So, for all three triangles, I had confirmed that all three sides had exactly the same lengths in every stage of the process. Using these results, I applied the side-side-side triangle congruence postulate to show that the original triangle was congruent to its reflected image, and that its reflected image was congruent to the final rotated image. So, by the transitive property of congruence, if triangle OQR is congruent to triangle O prime Q prime R prime, and triangle O prime Q prime R prime is congruent to triangle O double prime Q double prime R double prime, then triangle OQR is congruent to triangle O double prime Q double prime R double prime. So, as I said before, by the transitive property of congruence, this proves that the composition preserves congruence. So, now we have to understand why order matters. So, it's important to understand that the order of transformations changes the final position of the triangle. If I had rotated first 180 degrees counterclockwise about -10.5, 7, and then reflected across x equals -3, the vertices would have moved to different coordinates. So, the way I performed it, I reflected it across x equals -3 first, and then rotated it. I got Q prime located at -9, 8, and Q double prime located at -12, 6. But if I would have done it in the reverse order, I would have gotten Q prime located at -18, 2, and Q double prime located at -12, 2. These are different points. So, now, let's look at another example, vertex R. So, in the way that I did it, vertex R, originally located at 6, 8, vertex R prime became located at -12, 8, and then R double prime was located at -9, 6. But if I did it in the reverse order, then R double prime would have been located at -15, 2, and R prime would have been located at -15, 2, and R double prime would have been located at -9, 2. So, as you can see, the final triangle in the reverse sequence would be shifted and misaligned. This clearly demonstrates that rotation after reflection is not the same thing as reflection after rotation, and the order of operations in a composition directly determines the final coordinates of every vertex, which is why the reflection must come first in this project. In conclusion, reflecting triangle OQR across x equals -3 and then rotating at 180 degrees about -10.5, 7 successfully relocated the seating area into the correct park zone, the passive recreation area, or the Great Lawn area. So, throughout this entire transformation process, the triangle's size, angles, and side lengths were all preserved, and through the use of the distance formula, congruence postulates, and the transitive property of congruence, I demonstrated that this composition of rigid motions maintained perfect congruence. Thank you for listening.